Welcome, everyone. I'm Daryl Kaneinenbelt, your moderator for tonight's panel with Space Place Canada. And good evening to everyone joining us online tonight. I'm a communications strategist by day, but tonight I get to be a space enthusiast. And I'm very, very thrilled to moderate a discussion tonight between two distinguished experts. They will be delving into the wonders of astronomy and space exploration for our event tonight called Darkness and Light, Tips for the April 8th Eclipse. Let's introduce our panelists now. Dr. Elena Hyde, assistant professor at York University and director of the Alan I. Carswell Observatory. Say hello, Elena.
Hello, everyone.
Elena's work intersects astrophysics with data science, aiming to make astronomy accessible and engaging for all. And we also have Ian McClellan. Hello, Ian.
Hi, everybody.
Ian, with 35 years shaping planetarium projects globally, Ian has numerous accolades, including having an asteroid named after him. Ian also brings a world of experience in astronomy, infrastructure, and eclipse expeditions. So welcome to both of you. Tonight's event is really about practical eclipse viewing and safety tips, and also past eclipse travel experiences, which we are really looking forward to hearing from you, Ian, on. And for Elena to help us prepare for this big event on April 8th. Now, before we begin, of course, we have some housekeeping business. For our members, you all know what Space Place Canada is about, but for the new people to this space today, a quick recap. We are a group of space enthusiasts, academics, educators, researchers, students, even business people at Space Place Canada, and we are on this mission to advocate for a stellar addition to Toronto skyline, a planetarium. And we believe it's a beacon for families, enthusiasts alike. And the Space Haven really promises to illuminate minds through engaging STEM research and even celestial wonders. We really want to bring the marvels of the universe closer to home. Now, of course, we cannot do this without support from our members, our sponsors, our board, advisors, everyone that's joining it today and everyone that's watching. But our efforts are really made possible by sponsors like LTTS, Pratt & Whitney Canada, and MDA. We have a short video about MDA we would like to play for you now. Rolling that video. And if it doesn't come now, there it is. Wonderful, wonderful. Thanks again to our sponsors, and thanks for that video. Now, remember we were talking about the eclipse. Obviously, that's why we're here tonight. Glasses. Do you have your glasses? I've got my pair, but hey, if you don't, you still have the opportunity to get a pair of these from us here tonight. You can receive a maximum of 10 Eclipse glasses like these for a minimum donation of $100. So really easy, simple math. 10 glasses, minimum donation of $100. The deadline is midnight tonight. And in making that donation, we'll provide you, or you provide us with your Canadian snail mail address and specify you want the glasses. You get a tax receipt provided by Canada Helps. And the way to get this, just go to spaceplacecanada.ca to get those glasses. Also, glasses are also available at the LNI Carswell Observatory, April 2nd to 6th as well. So one more important thing about these glasses have ISO, International Organization for Standardization Certification, with an ISO number on it. You'll see it when you get them, 123122. Basically, that indicates that these meet international safety requirements, and they're certified by the manufacturer, Rainbow Symphony. So there you have it, our housekeeping. We've asked for some money, we've got some glasses, and now we're going to get right to the eclipse. And I'm pretty pumped about this. For the next hour and 15 minutes, we are exploring Ian and Elaine's inspiring career paths, the challenges that they've navigated, their visions for the future of space exploration, and their advice for the next generation of scientists, and of course, this massive eclipse. So it's going to be interactive tonight. Ian and Elaine will lead the conversation. They'll have a conversation here together. If you have questions, put your question in the chat. I'll find it, and then I'll ask the experts the question, and we'll have some more interactivity as the night goes on. So we got about an hour and 15. But first of all, I'm going to ask Elena the first question. Elena, and it seems like a very simple question. Elena, what is the eclipse?
Well, that's a wonderful question. So let me just go ahead and start our own little mini extra eclipse graphics here. So there we go. We're going to talk about the solar eclipse, and thank you very much as well for mentioning, of course, our joint adventure with Space Place Canada for the first Clear Day event on April 2nd to 6th. So coming up, very exciting. But what is a total eclipse? I believe that's the question. Well, the total eclipse is a particular kind of solar eclipse in this case. So we can have eclipses of different sorts. We're all probably familiar with a lunar eclipse where the moon turns red. Lunar eclipses and solar eclipses are all part of the same sort of eclipse phenomenon here on Earth. So what kind of eclipses can we have, and how special and amazing and cool is this one? They're all related. So just to get us started, I have to put on a first and foremost reminder. Anytime you're dealing with solar eclipses of any kind, please remember to not look directly at the sun. So amazing glasses, pinhole cameras, whatever you want. If you have a solar eclipse, what's happening is the moon, our moon, Earth's moon, is traveling around the Earth, and it moves in front of the sun. And it's actually able to block the sun's light, and it casts its shadow back down on the Earth. Now, this kind of solar eclipse can happen in a couple different ways. The moon might not block all of the sun. It might only be partial. And actually, solar eclipses are, a specific, sort of orientation. You have the sun, then the moon, and then Earth. If you have eclipses going the other way around, so instead of the moon being between the sun and the Earth, you let the moon go all the way around, and the moon can pass through Earth's shadow. So the sun is just out there shining all kinds of light, blasting the solar system, and of course it hits the Earth, and the sun-facing side has daytime. The night-facing side doesn't, and it's in what you might call shadow or shade. That shadow of the Earth goes all the way backwards towards our tiny little moon, and the moon can travel into it. So you can have this happen whenever the Earth and the moon and the sun all line up. So how many eclipses can we get? Well, we can get some eclipses happening every year, but you'll note that there's a little bit of a funny thing happening on this diagram. The path of the moon around Earth, which is both the purple line here, is actually tilted on, and this is an exaggerated scale, I have to say. This is not how the actual real scale. It's tilted at 5 degrees from what we call the ecliptic, so the plane of the solar system, where the sun and the earth and the moon and all the planets sort of line up. So this is maybe a little bit of a long answer to what eclipses are, but it all involves basically coming into line with the sun, the earth, and the moon. So if we have this 5-degree tilt, every time the moon goes around Earth, or once a month or a month, as we call it, approximately, our calendar system's weird, we have a chance of lining up. And when that alignment happens and you're on the ecliptic, we say that we've actually reached a node of the moon's orbit. So we could count how the moon is going around Earth in a couple different ways. We could count the phases because, of course, the phases of the moon track the month or the month. We could also count it as going from node to node. And there's some really fun things you can do with eclipses, but basically that's what they are. So I'm going to put a little eclipse graphic here that I love to sort of illustrate, because this scale is really, really wrong. And the moon is actually much, much smaller than the Earth, and much, 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 much smaller than the sun. In diameter, we have over a 400 times difference between the moon and the sun in the angular diameter. And that's, of course, we want to match that in the sky. So how is the moon, our tiny, tiny moon, blocking the sun? And this is a fun one. And of course, for a solar eclipse, very, very relevant, because you need the moon and the sun to have the same size in the sky for a shadow to be cast back on Earth. So this is basically, sort of to scale. So the bottom, if you can see here, that little tiny Earth and that little tiny moon are pretty much to scale with the distance from the Earth to the moon. And if you can imagine squishing that whole Earth moon down so that it fits between those two little yellow posts, you won't be able to see it anymore. It'd be incredibly small. But the sun would then be 400-ish times distance away. So the sun, it just so happens, we're kind of lucky, is about 400 times larger in diameter, but it's also about 400 times farther away. So the angular size in the sky just so happens right now to be the same for some eclipses, for total eclipses. Annular eclipses are a little bit of a different ball of wax. So of course, there are many, many different types of eclipses, but before going through all of them, I think maybe, it would be good to hear a little bit of a real eclipse story. Have you ever seen a total eclipse, Ian?
Yeah. Yes, in fact, Elena, I've seen 15 of them. I've chased 16, so my track record is actually pretty good. I had an astronomy friend at the University of Alberta, a professor there, who chased 11 eclipses all over the world and never saw one. He got rained on in Egypt, if you can imagine. So they are pretty rare, certainly rare at any particular point on the Earth. And that's why you have eclipse chasers like myself, because you actually have to travel to a place that intersects where the moon's shadow is going across the surface of the Earth.
Absolutely, and of course that shadow is not very big, because the moon is so small. So here's a graphic of approximately the right size, I hope, of the moon, that tiny little moon trying to cast its shadow all the way back through space onto Earth. And so, of course, if you're directly under the darkest part of the shadow, you do get totality. Everybody else in the region just gets partial eclipses. And that 15 eclipses you said, or 16, those were all total eclipses, correct?
Yes, 15 out of 16, yes, that I chased.
Amazing. And of course, you've probably seen a lot of partial eclipses as
Oh
well.
yeah, yes, yes. Those hardly even count because, as you mentioned, there's a huge difference between a partial and a total eclipse. And even if you're just 2 kilometers outside that band of totality, you won't get a full eclipse experience. You must be in that narrow band of totality in order to get the absolutely spectacular event that is created when you have a total eclipse.
Absolutely. And of course, I'll just pull up the eclipse map here for April 8th. And actually, we do have an interactive version as well if we want to zoom into that later. The totality center path is the red dotted line, and the dark red stripe is the region where totality will take place. Clouds allowing, I suppose you'll be able to see it. The light pink area outside of that says 90, so that's going to be 99.9 all the way to 90%. And then, of course, just to cross over into Sudbury, that's where it turns into an 80% partial eclipse.
And
Um,
Elena, lots of people think, well, 90 or 99% is all I'm really going to need. But I can't emphasize enough that if you're not in that darker shade, if you're not in that band of totality, you will not get the full effect of a total eclipse.
Yes, absolutely. That is a super important point because, of course, even at 99.9% or 99 point, I believe York University will be at 99.6%. We will not see totality. You will see a very thin crescent, which is pretty cool. So I'll put that up here. Here are some partial. Here's a little bit of a rundown between the types. So far, we've talked about total eclipses, which you've seen, partial eclipses, which I've seen. I have managed a few partials in my day, and annular eclipses. So I've actually not managed to see an annular eclipse because they are a little bit more difficult to catch than you would think. You do need special safety glasses or safety viewers as well.
Yeah,
Have you?
yes, I drove all the way from Vancouver to Redding, California to see the annular eclipse in 2011, I believe it was, from Redding, California. Saw it on the glass bridge designed by Santiago de Calatrava. And I was so glad I did. I didn't think, I thought it would be kind of a ho-hum event, but I wanted to chance it anyway. And so 1,200 kilometers each way later, I found out that it was really worthwhile doing even that.
So what's the difference from your viewing of an annular eclipse versus, for example, a total eclipse? Like if you
Well,
go out to see it.
that brings up a really interesting point, and that is even though you only got that ring of light coming through from the sun, that is extremely bright. The sun, you just can't you can't underestimate that the brightness of that ring. And so you need to have special glasses even to see the eclipse when it is only partially covered like it is in the annular eclipse until the moon completely covers the sun and you get only the atmosphere of the sun shining, then you must wear eclipse glasses. And there's so much mysteriousness around the idea of the safety and some misinformation as well. It's not the eclipse itself that's dangerous. A lot of people think that, my goodness, eclipse rays or whatever. It is simply the sun itself is so bright, and it's dangerous to look at directly anytime. And of course, the time that most people will be tempted to look up at the sun is during an eclipse, and so it's just looking at the sun is dangerous. It's not the eclipse itself.
Absolutely. And this is actually one that I got asked a little bit ago is what about our pets, our cats and dogs? Do we have to worry about them accidentally looking at the eclipse? And for the exact reasons you said, we don't need to worry about that because, your natural inclination, if something is too bright, is to look away. And For most pets, they will naturally want to look away from
Yeah.
any source of light that's too bright. And as you say, it's just a portion of the sun's light is still enough to really damage your eyes if you're looking directly at it. Plus, there's also the fact that you won't be able to see it. It'll be too bright to see the crescent of a partial or the beautiful ring of the annular if you don't have something protecting your eyes.
Yeah.
Elena and Ian, I have a question that raises a good question. So you talk about looking at it. We talked about glasses earlier, but can you photograph the eclipse with a phone? Can you
Uh,
take a picture?
You
yes,
can aim.
absolutely.
Yeah. Yes. You
But
can
will it
aim a
impact your
camera.
phone at all? Will it fry your phone by doing that?
No, no more than just taking any picture directly. If you held the camera towards the sun and held it in one position before or after the totality, there's a danger that you could damage either the camera itself, the equipment inside the apparatus of the camera, but under normal circumstances, no. And you could photograph it through the same kind of optics or glasses that you can see with the naked eye that that Space Place is providing.
Yes, exactly. And that's a wonderful. So you can get grid pictures. This is the partial eclipse that happened in Toronto in 2021. And these are all pictures taken from mostly cell phone cameras. The one thing you'll notice is that they're not directly looking at the sun. So your cell phone camera, you don't want to point it directly at the sun while a partial is happening. It's during totality, then that's safe. But if it's a partial eclipse or an annular eclipse, you want to be protecting your camera and also not looking directly at the sun. So you can use one of these indirect techniques. You can have, for example, a telescope with a solar filter, which is what you see on the left, or you can also have a pinhole or a box projector to create an image of the sun. So this is all partial eclipses. And of course, as the partial progresses, I'll just put this up here. You can have it be more and more partial to whatever maximum you're going to get in your area. And you can safely take pictures as long as your phone is covered and you yourself are not looking with your eyeballs into the sun. So that would be my big tip is, if you are in a partial area or even if you're going to totality, it's going to be a partial for most of its phases. So here's the phases of a total solar eclipse, and you've got a long period of partiality followed by maybe 1, 2, 3, 3.5, 4 minutes if you're really lucky of actual totality. So you most of the time you're using protection on your eyes and hopefully your camera. If you have 2 or 3 pairs of those wonderful Space Place glasses, you can sort of customize them, put a light lock, so securely block off the light, make a little filter for your phone or your camera that's going to be, so light only comes through the filter. They also sell ones that are pretty expensive. And of course, don't look with your eyes directly at the sun either. But there's a whole bunch of safe solar viewing techniques I'm sure we could talk about if people are interested in. The idea, of course, is anytime you're getting a picture of anything that's not totality, any kind of sun, whether you're just looking for sunspots or you're looking at a partial, don't look directly at it with your eyes or your phone or your camera or uh, your binoculars. That would be very bad. So, on lists of things to watch out for, I suppose.
But
But yeah.
you can project the image onto a paper from a telescope or binoculars or onto the ground, and sometimes there are ground effects that are worth looking at too. In other words, the eclipse
Yes.
can be the sunlight can be shining through leaves of trees, and the breaks in the leaves actually act as lenses, and you see these images of the eclipse right on the ground. It's a remarkable thing to see, and that's safe to look at.
Yes, exactly. And any kind of projection that you have is safe. Most of them, I would say, probably fall into like either a pinhole type projection or some sort of optic that has been used to project the surface onto something else. And the pinhole ones, those are really what they sound like. It's some sort of even hole that you're is in something that can cast a shadow, and you go and look and you get an image of the sun. So of course, we always like to point out to people, you don't have to buy anything for this. You probably have a pasta strainer in your kitchen that would work. This is a pasta strainer picture on the bottom left here, and I have it again somewhere else, I think slightly larger. The shadow of the pasta strainer, if you're looking at the shadow, and this is a little bit of a bigger picture, if you're looking at the shadow, in each one of the holes is a small image of the sun. And as it becomes a partial, they'll become crescents and then, go back to being full. So you can, just use a paper with a pinhole. You can make one out of a cereal box or a shoe box or any kind of box if you're feeling crafty. And of course, if you want to be a bit fancier, you can also use, as you mentioned, binoculars or a small telescope. I have heard, at least anecdotally, that you do need to watch out for any binoculars or telescopes with apertures much larger than 3 or 4 centimeters because you risk melting eyepieces in some cases. So you do want to watch out if you have optics, because of course we're in Canada. Most people have heard about camping and have heard that you can start fires with your eyeglasses by, using the eyeglasses as an amplifier of the sunlight. So if you can imagine binoculars doing that, I just would hate for anyone to accidentally set themselves on fire.
Experimenting with things like calendar for these images of the sun is a really great way to spend the time during the partial phases. As Elena says, there's a long time that happens between the beginning of the eclipse and actual totality, and a long time at the other side. And that's a good time to experiment with these kinds of things. It's just when it gets to totality, you want to focus on that because it only lasts for a couple of minutes.
Yeah, exactly. And there are many, many of these that you can absolutely experiment with yourselves. If you do want to build like I say, the quote unquote fancy one, I'll just put up the basic Eclipse projector box. So I've seen a lot of cereal boxes or shoe boxes used. It's just all taped up. And of course, there's other things that can also be pretty cool to observe around eclipses. Now, I don't know what the temperature is going to be like in April. It's been very bouncy in Toronto. But Ian, I know you have a pretty cool solar eclipse that happened at Lake Winnipeg, was it?
Yes, in 1979 in Manitoba, that was freezing cold. But the payoff for that, aside from the eclipse itself, which was in beautifully clear skies, was there was some high atmospheric haze, and it produced a magnificent display of halos around the sun. And it happened to be near solar maximum, so we had a fantastic display of aurora borealis at night around the same trip. So talk about a payoff that was just absolutely wonderful.
Oh, that sounds magnificent, of course. I mean, if it is going to get freezing cold, maybe we can hope for ice crystals. I don't know what our chances are in April.
We are close to solar maximum right now, so that produces some interesting sunspots on the surface of the sun, which are a wonderful thing to observe. And then the indirect effect of that is it produces auroral displays in northern Canada.
Absolutely. And of course, this is another wonderful thing that we can tell people to look out for. If you're going out anyways and you're viewing this partial eclipse, which everyone will get a good amount of partial eclipse if you're anywhere in Ontario, you will be viewing the surface of the sun and you might see little black specks on it. Now, depending on the size of the image you've projected, it might just look like a really tiny little black dot on a tiny little circle. But if you can project it reasonably large, there's some really impressive sunspot clusters. And right now, just rotating out of view is, I believe, the largest sunspot cluster of solar cycle 25, which we are currently in. So the sunspot activity at the moment is, I suppose we're going, harkening back to your Winnipeg experience near solar maximum, with all of these amazing sunspots.
Yes. An interesting thing is, if you took one of those sunspots away and took it away from the sun, it would actually be very bright. They just look dark because they're relatively darker than the rest of the sun, but they're actually quite bright. And you could fit several Earths into any one of the larger dark spots.
Yes, absolutely. And this goes back to that sort of the scale of solar eclipses is really absolutely mind-boggling. So I just want everyone to look at that left side picture of the sun and try to remember how big these black dots are. And then I'm going to go back and I'm going to show you again this image of the Earth and the moon. At the bottom, that's the left side is the Earth, right side is the moon. Now, if I was to put those in the same scale so that the size was correct, near the surface of the sun, it would be these big dots. So that little tiny dot would be the Earth, and the one that you can almost certainly not see would be the moon.
You could
So
you could
that's
put
your scale.
yes, you could put 1 million Earths inside the surface of inside the globe of the sun.
Yes, exactly. It's the volume is tremendous. I think it's something like 64 million moons or something. Ridiculous. Approximate. Don't quote me on that.
Well,
Um,
Elena and Ian, I'm going to take this opportunity at kind of the halfway mark for those of the attendees who are joining us for the Space Place Canada event. If you've just joined us, you have been listening to Dr. Elena Hyde. She's the assistant professor at York University and director of the Alan I. Carswell Observatory. Her work intersects astrophysics with data science, and her goal is to make astronomy accessible and engaging for all. And also, Ian McLennan, who you've heard about his eclipse chasing adventures. We're going to hear more. They're amazing. Ian, I'm fascinated by these. Ian has 35 years shaping planetarium projects globally. He has numerous accolades. And at the beginning of this, Ian, we introduced you. You have an asteroid named after yourself. Can you tell us about that?
Well, that was a real honor. There was an observer at the Royal Astronomical Society of Canada in Edmonton who discovered this asteroid, and he wanted to honor me because of the work I've done with museums and planetariums, and specifically in Edmonton. So I was truly honored to receive that, and it's a lovely thing to have on your resume.
No kidding. Well, and I'm equally honored to be able to speaking to both of you as well today. And a reminder to our attendees, please put your questions in the chat if you have questions for Ian and for Dr. Elena Hyde. This is your chance to get started with that and think about different things when it comes to the eclipse. We've learned a lot so far about safety, sunspots, what to do, what not to do, in terms of what's happening with the eclipse and why it's so relevant this time of for this year. Because my understanding is we are not going to see another one for many, many years. Dr. Elena Hyde, when will be the next one after this?
Total eclipse in Ontario, not for over 100 years, more like 120 or so. So if you're in Ontario, this is really an astonishing chance. I think it's safe to say that a lot of us are very, very excited about the idea of being underneath the black spot of the moon's shadow and getting to see something about being able to really see the scale in motion. That really captivates, I think, at least my imagination. So I'm very much looking at trying to actually understand the true scale of the solar system during this eclipse.
Are there ways that scientists plan to study this eclipse once it's done?
Well, I mean, the eclipses have traditionally been used for all kinds of interesting things, tests of relativity and, the size, actually initial estimates of the sizes of the solar system and fun things. This particular eclipse, to my knowledge, most people are really just using as an excuse to go out and do solar weather viewing,
Yeah.
because of course the uptick in sunspots has made it a really, really active area for everyone involved in solar astronomy.
Very often during an eclipse, there are researchers who analyze the effect on the upper atmosphere. The very first eclipse that I chased back in the 1960s was in Fort Providence in the Northwest Territories. And Alan Clark from the University of Alberta in Calgary had big balloons that he set off up into the upper atmosphere at that same time. That incidentally was an eclipse where the priests warned the native people that the reason that the eclipse was happening was that God was punishing them for being bad people, and he was sending the eclipse as an omen. And we went on local radio to rebuke that. So we weren't too popular in some part of that community, but we felt that the record had to be set straight.
Yeah, absolutely. And of course, when you're talking about research as well, there's of course atmospheric, as you said, but also a lot of non-astronomical research in terms of animal behaviors. And I think you've seen some pretty interesting things on some of your adventures.
Yes, it's interesting to watch animals and birds and their reaction to the eclipse. However, one of the problems is the eclipse lasts for the totality lasts for such a short time, and you want to focus on the sun. But certainly, animal behavior scientists have been fascinated by that. But typically, you hear roosters crowing and you hear other kinds of things happening out of sequence in the middle of the day. So it's all part of the phenomenon that your world is turned upside down for that very short period of time, and all kinds of things happen that are unexpected.
There's a
Well,
question in the chat, by the way, and this might turn you upside down with this because we're moving from animals to colors. Do you know anything about wearing green for the eclipse? Something about how the eclipse affects how we see different colors? Any of you want to take that one? And then I have one more after that.
Well, a green filter isn't good enough to look at the sun itself. It might be interesting to look at the totality with a green filter. It's always interesting to experiment with all that kind of thing anyway, just as a matter of personal interest. But a green filter by itself would not be safe to look at the partial parts of the eclipse. You must look through welder's glass, number 12, I believe, or the kinds of glasses that have been approved by Space Place and other reputable observatories.
Do
yeah,
you do
exactly. It's the I have heard the wearing red one though. Which I think, the idea is that if you have totality, the sky goes dark. And are there certain colors that are going to help your eyes adjust better? And I think that might be what the question is kind of getting at. Now, it's true that in dark, low light conditions, your color cones in your eyes are not very sensitive. As far as I know, green wouldn't do much. But if you do want to help your eyes get adjusted faster, don't use white lights on your phone. Like, don't turn your phone flashlight on white lights. If you want a flashlight, bring a red flashlight. It might help. But your clothes, I don't know about that. I think that might be something different.
Yeah.
Good. That's good. Great information. I never would have thought of that. But thanks for that question from the chat. I hope we answered that. We have another question for each of you. Which was the most memorable total eclipse you have seen live? Ian, I'm going to go first with you.
Oh boy, that's the most difficult question to answer because every single one of them has been special. And it's not just the eclipse itself, it's usually in the context. I saw one in Indonesia and there was gamelan music playing in the background. And it was the first time I'd ever heard gamelan music. I saw an eclipse in Kenya and the Bombas of Kenya, a fantastic dancing group, was dancing. And the drumming and so forth was spectacular. There was an eclipse in Shanghai, China that we actually missed. It was the one that I missed, but it was spectacular because the eclipse triggered a downpour. The sudden cooling of the temperature created a cloudburst that just absolutely drenched us at the time it went dark, and then circus lights came on with a circus organ playing. It was the most surreal thing you could imagine. There was an eclipse on board a ship on the Black Sea, and the night before the eclipse, the captain turned all the lights off on the decks, and we went towards the Perseid meteors and watched them in August. And then the day of the eclipse, there were several ships parked, and the captain of our ship knew enough to make sure that the lights didn't come on the deck. But the other ships we could see they had novice captains, and just as it got dark on those ships, all the lights came on, and the people who had paid thousands of dollars to come see the eclipse on board these ships missed it, so or at least had a bad view. So every one of them has been a special adventure.
That's great. What about you, Elena?
Well, I haven't seen as many, but I would definitely agree with Ian that, the situation matters a lot and where you are and also who you're with. I was pretty lucky well, lucky and unlucky around the same time. When I was younger, I had a pretty serious operation, but when I was recovering in hospital, my mom was there and she actually got permission with the nurses to put me in a wagon and take me outside. And I think, I think I was probably 8 or 7, but it was a lunar eclipse, and it was the first one I ever saw, and it was spectacular. It was an absolute blood red moon, and it was a weird time, and you got to go with people who are important to you and see this event of, and in my case, it was actually not a solar eclipse, it was the moon moving into Earth's shadow, in particular into the darkest part of Earth's shadow, which we haven't talked about too much. We have the umbra, and getting to be that beautiful bright red, color that it does get when you have a total lunar eclipse.
Yeah,
So
lunar eclipse is really a very pretty thing if it's really bright red.
yeah,
Great stories.
absolutely.
Those are amazing stories. So many. I mean, you must have so many more to share. I wish we'd have some more time, but maybe we'll have at the top of the hour, we can share a few more of those as questions come in. I did have a couple more questions coming in as well that we want to get some feedback from you on. There's been lots of talk about schools closing for eclipses, perhaps some misinformation in regards to the whys of that. But we talked about this earlier in terms of why it's important that schools being released. Most kids get out of school at 3 o'clock. This eclipse is happening at that same time. Ian, did you want to touch on that in terms of it's great that schools are giving kids a PD day or a day off to view the eclipse, but there's actually some great reasons for that. It is a safety reason, isn't it?
Well, that's part of what gets misunderstood, and that again, the thing that's unsafe is to look at the sun anytime. I remember in Indonesia once, during a total eclipse, the government was so spooked about protecting itself against any backlash from the public that they ordered everybody to stay indoors all day with their windows closed, the blinds shut, and the doors locked all day. Um,
Mm.
and it was crazy. And millions of people missed this wonderful event. So in terms of school, I think it's wonderful that the kids will get a chance to see the eclipse. I think that one of the considerations was there was a concern that they'd just be getting out of school as the eclipse was happening. and they wouldn't be in a situation where they could be adequately supervised in terms of safety. Is that your reading too, Elena?
Well, it is a bit of a double-sided sword for me because on the one hand, as as a scientist, I would say, we want to be out there seeing it with as many people as possible. And as an educator, I pretty much see the same thing, but it's a great chance for an educational opportunity. However, I can understand where they might be running into trouble with, some of the schools having to close just before the peak, either maximum, partial, or totality actually happens. And, if they're required to close and everyone has to leave and it gets chaotic, I could understand why, of course, maybe it's better in those cases to just, have everyone stay home. So I can sort of see, I suppose, both sides there in terms of, on the one hand, you would love to be able to share this, learning experience and eclipse viewing with as many people as possible. But if you do have classes ending right at that time, how would you logistically arrange it, and is it even possible? And of course, there is a safety thing as well, because anytime you do have an eclipse event, you need to make sure that you run everyone through safety so that you don't have people trying to watch the solar eclipse or look at the sun with their naked eyes when it is only a partial, for example.
Mhm.
So yeah,
Good.
I can see where they're coming from with it.
Good conversation. And for sure, I mean, if anyone, even on the chat or anyone's watching tonight, if you have any questions, I would just encourage you to go to your school board's website, district website. There'll be information there in terms of how most school districts are, working on that day or planning to address that issue of having students being off that day to watch the eclipse. Still back to the chat, we have another question talking about temperature. This is a good one. Temperature change. What temperature change might we expect in Toronto during the near totality? Helena
In in
or
in
Ian, either of you.
in Toronto, which is just on the outside of totality, you will notice a temperature change. It will get perceptibly cooler as it gets closer and closer to the maximum of the partial. But it's not a huge temperature change, but sometimes you do get a noticeable change as soon as totality happens, and then you get chills, and then you're excited, and on top of it, so it adds to the. But a lot depends on what the ambient temperature is at the time. But certainly you can expect several degrees centigrade change.
Yeah, and as you mentioned in one of your stories as well, this temperature change can trigger weather events. So I'm really hoping we don't get a storm like you had
No,
before.
a cloudburst is not the. It was a wonderful thing for us because we'd already seen several eclipses, but for other people on the trip, it was disappointing for them because they were hoping to see a whole total eclipse.
And at some point, I believe you also got a flood. Was that related to the temperature inversion?
No,
And
no,
so
that
that
was
was in Mexico, right?
yes, that was totally unrelated. We just simply got trapped between two rivers that had flooded, and the bridge got washed out, and we were trapped in an untenable situation. Had to get our car towed across the river by oxen on a raft, and it was crazy, a crazy adventure. But that's all part of the deal.
Well, I mean, they talk about, animal behavior during eclipses. I guess nobody thought about oxen. Um,
Yeah,
That's a totally different set of problems. But
I
yeah,
didn't.
temperature change in general, I think, Toronto is what I would describe as very bouncy. As an Australian who's moved here somewhat recently, it seems like we already have a bit of a bounce to the ups and downs of Toronto weather. So I mean, maybe we will get a burst into freezing and see some cool, ice crystals or something.
It's one of
I
the
have a,
things worth measuring if you're interested. If you're observing an eclipse, it's always interesting to be aware of all the other things that are happening, and so measurements of the actual effect on the atmosphere would be an interesting thing.
Yes, that is so true. And that is actually an excellent, excellent point because if you go to see an eclipse with people who do have any kind of disability, there are ways that they can join in. And as you mentioned, temperature measurement is actually one of those ways. You can bring a digital thermometer, even the ones that speaks, and they can follow along as the temperature changes. And also there are I forget exactly what it's called, but there are Python apps that will measure the change in light intensity for you and also speak the decrease for you. So you can actually use that same idea to if you are hosting an event to add accessibility to your eclipse viewing, which is anyways.
I have this. My next question is really about inspiration for both of you. Hearing your story as an eclipse chaser, Ian, and then for you, Elena Hyde, and your profession. I guess my first question to Ian is, how does someone become an eclipse chaser, and what motivated you to start that? What inspired you to do that?
Well, that's an interesting question because in the going back to the 1960s, it certainly wasn't as big a deal. Not as many people chased eclipses then. It has kind of caught on, and so there's a whole bunch of people. I mean, thousands of people who travel all over the world to see eclipses now. And that wasn't true in the early days. But for the very first eclipse that I chased, it was in the early 60s and living in Edmonton, and there was an eclipse happening in the Northwest Territories, which was either close or far, depending on how you looked at it. But it was relatively close, and so but once you see one, I'll tell you, you get hooked. You absolutely get hooked. And almost everybody I know who has seen one total eclipse makes a point of trying to get under the moon shadow at subsequent eclipses after that. It's such an overwhelmingly amazing thing to see and experience. It just catches on, and there's nothing you can do about it.
What about you, Elena?
Yeah, so I mean, obviously, I love I love the idea. I think I probably will end up getting hooked if I get to see this one. And I've always loved observing of any kind. It's one of the reasons why I got into astronomy and why I stuck there. Is I ended up in Arizona where the skies are quite good, and I had the opportunity to do a ton of different kinds of observation and yeah, the more you go out there, the more mysteries you're going to find, the more things you're going to get to see that you've never seen before. So it really is, exploring the universe. And of course, the great thing about it is you never really know how it's going to turn out. And I think this is true of eclipses and science in general. And for me, I loved the mystery where I could look at something in astronomy and go, "Oh my goodness, I have no idea what this is." Like this is just I have just never seen anything like this before. And
And
so if you like that,
and when you've chased a lot of eclipses, you get to worry about whether you'll be blasé this next time around. I've actually worried about that. And every time I'm just simply overwhelmed. My daughter Susan came with me to the last one in Oregon in 2017, and she always appreciated the fact that I had this hobby of chasing eclipses, and just thought, well, that's very nice. But she came along with me, and she was so overwhelmed when it happened, and it was just an amazing thing to share it together with her. And that anticipation is one thing that is a common thing too. There's a lot of excitement just leading up to an eclipse. There was one chap, I'll name him George. In fact, that was his name, who was on a shipboard experience chasing an eclipse, and he got so excited before the eclipse that he had to go find a washroom, and he went down into the holds of the ship, and presumably found a washroom, but he couldn't find his way back out again. He got lost in the labyrinths of the under the decks of the ship. He got lost in that labyrinth, and he could hear the cheering and the excitement of the whooping and hollering up above. And you could have just imagined what that did to him. He never forgave himself. So, but it triggers a huge amount of excitement, as you can imagine.
Oh my gosh. Yeah, I can totally imagine. And this is a great lesson for anyone watching. Go to
Yes,
the bathroom well before.
well before.
It's we have another question here in terms of sites, and thank you for sharing that. Those are great stories. That really, before I get to the question, those were remarkable answers, because it also speaks to the beauty of science, wonderful of science, your adventures as well, and the curiosity, and even what Space Place Canada is about in terms of tapping the curious minds, STEM research, exploring the universe. All those things just intertwine so nicely with what we're talking about tonight. And for any kid, anyone watching who wants to be inspired about a career in space science, like, this is what a great forum to be able to speak to such great experts and their stories. So thank you for that. We have a question here as well in terms of a site where you can track time, place for total eclipse for other locations, like in Arizona on April 8th. Do you have any insights on that?
I'm loading one of my favorites right now. So let me just adjust the size of this.
Ar-
This is one I've
Arizona,
been using.
yeah, Arizona will miss the totality. It'll be a partial eclipse in Arizona, but a lot of people from Arizona are going to go either south to Mexico, Mazatlan, and places like that, or east to Waco, Texas, or Dallas, or places like that.
Yeah, that's a great point. Is if you have any other sites that you're thinking about checking, so Phoenix, Arizona has about a 40% or no, sorry, Phoenix has 64%. I'm just going to put it in. This is the time and date eclipse map. So if you haven't seen this before, it does let you zoom in and out. You can find locations in Mexico. You can find locations in the US. And just in case our crew can put it into the YouTube chat as well, it's timeanddate.com/eclipse/map 2024 April 8th. And the eclipse path, as you can see, it goes through Mexico, up into through the U.S. Into Canada, and it sort of runs through the edge of Canada and then up through Newfoundland and Labrador, and back into the ocean, which is of course where lots of eclipses have lots of their eclipse paths. So if you have any questions about your specific area and anywhere along here, you can see that that huge amount of North America will be able to see something. So Phoenix has a partial, even Los Angeles, all the way in California, now they get 48% partial. So if you
There
want to
are
go
there
West
are
Coast,
Yeah, there are several American cities that have the totality, like Cleveland and Buffalo and a couple of others. So there are a few major cities in the U.S. that will get the totality.
yes, absolutely. There's Cleveland right next to the red dotted line, Buffalo, New York, and going back down, of course. I know one popular location for travelers. I've heard a lot of people saying that they're going to drive to Texas. So here's Dallas and Waco and Killeen and Austin.
Waco is in McLennan County, by the way.
Is it any relation?
No, no relation, but I know
Wonderful.
of.
I have another question. How long is the cycle from start to end for the shadow to pass if you're in a band of totality?
So I'll leave this up actually for that question. So if you are in totality, how long it will last will depend on where you are. So I'm not sure, they didn't put a location in there. So I'll just go back up to Canada here and zoom in a little bit near Toronto. So as you can see, Toronto does not have totality, but here's the red band. This has totality. However, if I go to Hamilton, it's 1 minute 50 seconds for totality. And so I think they're asking, how long is it going to last? So your totality will start at 3:18:12. So 3 minutes 18, or sorry, 3 hours 18 minutes 12 seconds. Maximum is at 3:19:07, so less than a minute later, and it ends at 3:20:02. So that's seconds. So you have 1 minute and 50 seconds of totality as the shadow goes over you. If you go to St. Catharines or Niagara, you get more totality. So it takes longer for the shadow to pass over you because you're more near the center. So this is 3 minutes 31 seconds. And if I get closer and closer to that red dotted line, it goes up to whatever you can get to. So 3 minutes and 46 seconds in Buffalo. And then as you start going out the other side, wherever this is, going back towards the edge of the red zone, you go to smaller and smaller times. So if you want more totality, go towards the dotted line. The closer you can get to the center, the more you're going to get. And of course, it will also change a little bit depending on where you are. And this is one I left out earlier, but I can pull it up now. So this particular eclipse is very well documented on a wonderful website called Eclipsewise that I super recommend. It has all kinds of great stuff. And this eclipse is part of what's called Saros cycle 139, which is part of an eclipse family, and it will have a relatively long total eclipse. So its duration at the greatest eclipse is 4 minutes and 28 seconds. So the best you could do for this eclipse would be to go into Mexico and get the 4 minutes and 28 seconds totality. So I think, if you were curious about your own locations, again, I would recommend the interactive map because that will let you sort of drag around and look at different places that might be near you. But as Ian cautioned before, if you are close to this red line, even if you're really, really close, so let me just zoom in here a little bit. So the red line is now, here's Burlington, there's Oakville. I'll go really close to the red line. I'm right next to just Oakville, outside of the red line, 99.99%. That's a partial eclipse.
Yeah.
So you're
No.
not going to get totality.
Yeah.
That's
So watch
fascinating.
out for that.
Okay, is there a possibility, because one of the people in the chat, Rosie, wanted to know about Prince Edward Island. Is there any way to zoom that out and see where it lands in PEI?
I think they missed it.
Prince Edward Island. There we go. There's Prince Edward Island. So here's totality. This dotted line is off of the coast. So there's your Prince Edward Island. It looks like the northern part of the island will have totality, but the southern won't. So you'll have, if you go up to the coast here, here's Carlton. They're going to get 2 minutes and 52 seconds, of totality. But Charlottetown down here, they do not get any totality. They have a 99.56 partial. So this island is cut in half. Half of them will see the eclipse, half of them won't. Very fun,
The
actually.
Eclipse just doesn't want to share everything, does it? It just wants to
Nope,
split it in half.
it's going to split in half Prince Edward Island, and it's also splitting in half Montreal. So if you're in Montreal, make sure you're on the right side.
Yeah, but yes, part of Montreal is within totality, and the south part, no, it's the north part that is.
Yeah, there's the south part of Montreal has it, and the north part does not.
That's correct. Yeah.
So yeah, watch out for those cities that are half or
But
locations that are split up.
the totality would just be a few seconds in Montreal. It'd just literally be totality for a few seconds, and then
Oh no, you Montreal has 1 minute 27 seconds.
my goodness, mountains.
So if I zoom in a little bit, you can
Okay,
see that
yeah,
the actual edge
check.
of
I,
totality. So if you go the downtown Montreal, so the real downtown area, I think is probably here, although some Montreal people can correct me. This is 1 minute 21 seconds.
okay,
But if I go across town here to wherever this is, so Montreal folks, let us know, 37 seconds.
yeah,
So and if you go across this river, here's Brossard. I guess this is a neighborhood, suburb. 2 minutes and 2 seconds. Um, La Prairie, 2 minutes and 11 seconds. So as you see, the farther you go down towards the dotted line, the better you get. But yeah, if you're right on this street, and this is the fun thing, of course, I love zooming in. So here's the line of totality. You could be on this highway, which is you could be on this highway and drive yourselves into totality. That's Rue Salaberry 4 looks like. So you could be driving along and you'd have nothing, nothing, nothing. So a partial, and then bang into the total solar eclipse right as you go across Rue de Salaberry here. So you can, and this is 10 seconds, so you'd only get 10 seconds of totality. Blink and you'll miss it. But keep driving and go south, go towards the dotted line, and it'll get better and better and better.
Speaking of
So
driving, I saw an eclipse, total eclipse in Nova Scotia once, the one that was made famous by Carly Simon. And I noticed that there were truck drivers that just kept on driving, and they just simply switched on their headlamps when the eclipse totality happened. There we had gathered in Nova Scotia from all over the world, and in order to see this thing, and people would just kept on driving through the eclipse.
so where in Nova Scotia were you?
That was boy, I can't even remember it. It's I'd have to go back to my notes now.
Oh, that's all right. I was just wondering, it's compared to this eclipse. Of course, Nova Scotia will be getting a partial. Halifax will be getting a 94.44. And I believe, and I'm not entirely sure where exactly the border is with New Brunswick, but as you go across
Yeah,
here-ish,
Moncton is in New Brunswick.
yeah, so that's just outside of totality.
Yeah.
So just as you go from Nova Scotia over into New Brunswick, you start getting totality again. So in this case, I suppose New Brunswick is lucking out and Nova Scotia not so much.
Mhm.
Well, on that note, I'm going to use this opportunity to again show glasses. Rosie, if you don't have your glasses, you know where to get them. I talked about this when we opened up. Many people have been vying for these glasses. These are Space Place glasses for the Eclipse. Tonight, we're offering these 10 for $100. Deadline's midnight tonight. And if you make a donation, provide us at Space Place Canada your snail mail address and specify you want these glasses. You'll get a tax receipt provided by Canada Helps. And so if you want the glasses, for anyone watching, go to spaceplacecanada.ca. 10 for 100, great donation. Get some for your families. It's a great way to stay safe wherever you are. And as you know, geography matters. So if you're on Summerside versus Charlottetown, maybe give some to your friends there, wherever you are located across the country. We have about maybe 7-10 minutes left as we wrap up here, Ian and Elena. Are there other things in terms of your experiences, chasing eclipses that really stood out to you? Like you initially talked about how it makes you feel, but I wonder if you could unpack that a bit more in terms of what is it about that eclipse and that's kind of celestial event. You look up to the sky and this is happening. You can't control it, but it's happening for 3-4 minutes. What does it do for you?
It makes you connected to the universe, and I don't know how else to say it. It's something that as you look up, and at that moment of totality, when so much changes, that little sparkle of sun that just disappears behind the moon, and all of a sudden it's dark, and the planets come out, and you see a sunset glow around the whole horizon. And then you hear, if you're with people, you hear the whooping and the hollering and the just the visceral reaction. And as you're looking at this thing, and I tend to look at it through really good binoculars, it takes you and places you in a celestial bubble of some sort, and that it just envelops you in something that is otherworldly. I don't know how else to describe it.
I think
It's
that's a
described.
wonderful way to put it. It's, it sort of connects you to our solar system, really,
Yeah.
and to the vast, amazing scales involved. And I mean, I do think if we only have a couple minutes left, I'm just going to talk about this in the context of the skies going dark because I love the stars, and I am extremely excited to be able to see our sun and our stars in the sky at the same time. And this eclipse is going to be spectacular if clear. So if you can get to dark sky sites, and this is why I don't tend to recommend Niagara Falls. They might, I don't know that they're keeping all their lights off. So you want to have dark skies. The Milky Way will be there. You'll have Saturn, Venus, the eclipse, Jupiter, and flying out from Jupiter, we have this amazing comet that's a 71-year period comet, which is coming by not again until 2095. So by the time the eclipse happens, it ought to be around magnitude 4, visible to the naked eye. And this just seems like a conjunction. Well, it seems like an amazing view to be able to see, and I really hope, even if it's cloudy wherever I am, somebody gets some pictures because
I,
this is just
I think
really cool.
to see the comet, you'll probably need really good binoculars or a good telescope, but it's certainly worth looking at. But you'll certainly see Venus and Jupiter and possibly Mercury, and some of the stars of Orion should be visible as well.
Oh,
Some
and
of
the Pleiades, yeah, the Pleiades are up as well.
Yeah.
So there's some nice bright things that will be pretty easy. Yeah, the comet, I'm not really sure how bright it will get. I don't know if I believe that it will be fourth magnitude. But Saturn should be pretty bright. And yeah, of course, the Pleiades being up, those are always spectacular. So there's just all kinds of reasons to go out and, as I say, look uppity.
Look uppity. Well, that's a great way. That's a great way to wrap things up here for tonight as well. But maybe just some final thoughts as we come to a close, Elena, and then Ian, of what we spoke about tonight. The big event, April 8th, coming up with the eclipse. One of the big events of this year for sure. Any last thoughts, Elena?
Sure. Yeah. So I would say that I'm just going to use my last thoughts to agree with Ian. This is a wonderful chance for everybody to be involved with our solar system and with not just our planet, but our place in the universe, so to speak, because we talked about the moon going around the earth and the moon, of course, go around the sun, and these cycles that we see over the course of months and years have been documented. A lot of times they're linked to our location on Earth and go back for human history for thousands of years. So I would say that it's my final thought would be that this is definitely one to catch if you possibly can.
And the only thing I would add to that, it's a wonderful thing to share with a loved one or with a friend or with family members or with friends. And if you're in a big group, you'll be amazed at the reaction, especially right at totality. And it's a wonderful thing to share with young people as well, to bring them along and get them to appreciate that there's so much in the universe that is so visceral, so exciting to see, and just share it. There's nothing like it.
Well, thanks for those thoughts, those closing thoughts. Those are great. And I think to be able to share this platform with you and for everybody else that's been on our event and joining our event tonight, I'm sure they would say that I've learned many things about eclipses tonight. I never thought I experienced lived the real life of an eclipse chaser. And this is something I never thought I'd experience as a space enthusiast. So before we close, one last part of housekeeping. I want to promote another event coming up April 2nd, Tuesday, April 2nd. Speaking of space, we're moving from eclipses to medical services, long distance healthcare, delivering medical services in space and on Earth. We're going to learn how Canadian companies are tackling the challenges of remote healthcare, believe it or not. A topic, healthcare related to space, and here we are talking about this in 2024. It's 7 o'clock, April 2nd, 7 to 8:30. You can register at Space Place Canada, so spaceplacecanada.ca. Also go to that same website, get your glasses there as well, and register for any events. And if you haven't become a member yet, please do so, sign up. It's a great organization. I've joined as a volunteer and as a space enthusiast to help see the fruition of a planetarium come to life in Toronto. And so have so many other people here on this chat today, including Ian, members of our board and advisors. So again, a heartfelt thank you to our panelists, Ian McLennan and Elena Hyde. We thank you both for a night of insightful conversation, and have a great night, and everyone have a safe night and a great week. Bye-bye.
Clear skies.